Hello. Now, in this lecture, we have discussed regarding the example related to JFET. Example related to JFET. JFET means function junction field effect transistor. Already discussed this concept in the previous lecture. So now we have started what is the what is the fundamental role that we have identified based on the characteristics of JFET. So I have write this word here. Please see carefully. This is the first point. What is the full form of JFET? JFET is known as junction field effect transistor. Junction field effect transistor. Now, uh, what is the meaning of pinch of voltage? What is the meaning of pinch of voltage? This is the content that we have discussed in the previous lecture. What is the meaning of pinch of voltage? Pinch of voltage means pinch of voltage means value of value of drain to source voltage, drain to source voltage, after which after which drain current drain current is considered as a constant current. So this constant current is this constant current, whatever voltage is present, is known as pinch of voltage. Means what? Now see this. If I have sketched the characteristics of JFET, see this. I have mentioned here voltage VDS. Here I have mentioned the characteristics. I have mentioned the characteristics. See here VGS equal to 0 volt. Here VGS equal to minus 1 volt. Here VGS equal to minus 2 volt. And see here current is known as ID. ID current. VGS equal to 0, VGS equal to minus 1, VGS equal to minus 2. Now see this. What is the meaning of pinch of voltage? See this. This is known as pinch of voltage. I have mentioned here the voltage notation V, which is known as pinch of voltage. Means what? It is known as pinch of voltage. After this, drain current, which is equal to consider as a constant value. So I have also here sketched the graph. Up till now it is constant. So sketch this, and now onwards, see this. Here it is known as at VGS equal to minus 3 volt. And here below VGS equal to minus 4 volt, drain current which is equal to 0. So it is the characteristics of N channel JFET. It is the characteristics of N channel JFET. It is considered as a saturation region. I have mentioned this here. It is considered as a saturation region. It is considered as a saturation region. In saturation region, JFET act as a in saturation region, JFET can be act as an amplifier. JFET can be act as an amplifier. JFET can be act as an amplifier, and it is indicated. See this. It is the region which is known as ohmic region. Which is known as ohmic region. It is considered as a ohmic region. In ohmic region, it can be act as a on switch, or we can say in ohmic region, it can be considered as a voltage variable resistor. In ohmic region, it can be considered as a voltage variable resistor. So it is the application of JFET in the different region. Saturation region, it can be act as an amplifier. Ohmic region, it can be act as a VVR, or we can say voltage variable resistor. And see here, it is known as cutoff region. Cutoff region means off switch. Cutoff region means off switch. It cannot be act as a it cannot be act as a current flow device. So it can be act as a one type of open switch. In ohmic region, it can be act as a on switch, or we can say short circuit. So it is the entire concept related to JFET. It is the most important according to GTU syllabus. Please carefully prepare. And if you want to understand the VLSI concept at that time JFET, MOSFET, it is the pure foundation. Remember that point. And based on the VLSI, there is the lots of job opportunities. So please try to prepare this very carefully. Now I have sketched the symbol which identify the difference between N-channel JFET and P-channel JFET. See this. See this. See this. This is known as gate terminal. This is known as drain terminal. This is known as source terminal. Now see, if you want to sketch the symbol of N channel, if you want to sketch the symbol of N channel, if you want to sketch the symbol of N channel, that's why it is considered as a P terminal, and between P, it is known as considered as a N material. So current flow direction is P to N. See this. This is the direction of current P to N. Please carefully see this very carefully. This is the symbol, inside symbol. Now similar for P channel JFET. Similar for P channel JFET. Similar for P channel JFET. I have sketched the symbol. Here it is known as gate. Here it is known as drain, and here it is known as source. But but for P channel JFET, but for P channel JFET, symbol can be considered as the outside. See here N, here N. Sorry. Here P, here P terminal. Due to P channel JFET, here drain and source is P, and gate can be made with the terminal of N type of semiconductor. And direction of source to gate is outside the direction. That's why it is known as symbol of P channel. That's why it is known as symbol of P channel. So here we can mention symbol of P channel. It is the difference between P channel JFET and N channel JFET. Now I have shared the PPT related to that JFET portion. So I have explained this all the concept related to that. Now see this. Derive the equation of transconductance. Derive the equation of transconductance of N-channel JFET. Transconduction means what? Opposition of trans resistance. So at that time, first of all, you have to consider the characteristics of transfer characteristics. What is the meaning of transfer characteristics? It is the sketch between VGS and ID. I have again sketched with the help of a whiteboard. So you have to explain this. You have to explain very clearly. Whiteboard. See this. This is the characteristics. Here we can sketch VGS. VGS means what? Again repeat. Gate to source volt. VGS means what? Gate to source volt. And here we can identify the ID. ID means what? Drain current. So with the help of applied gate to source volt, we can able to control the drain current. So it is known as voltage control device. So at VGS equal to 0 volt, consider here VGS equal to 0 volt. So maximum current can be flow. Maximum current can be flow in the entire circuit. Now see this, at VGS equal to 0, maximum VGS equal to 0, maximum current flow. Now VGS equal to minus 1 volt. So minus 1 volt current can be decreasing like this factor particular. See this. Now see here we can say consider here minus 2 volt. Here consider minus 3 volt. Here consider minus 4 volt. So if you can increase the gate to source volt, then drain current is reduced to 0. If we can increase, if we can increase the drain to sorry, if we can increase the gate to source voltage, then drain current is decreased. Drain current is decreased and reduced to 0. Reduced to 0. So it is known as transfer characteristics. Remember that point. This is known as transfer characteristics. Plot between VGS and ID. Transfer characteristics. Transfer characteristics. Plot between VGS and drain current. So it is the biggest difference between transfer characteristics and output characteristics. Transfer characteristics plot between VGS and ID, and output characteristics plot between VDS and ID. So it is the fundamental difference. So might be helpful in the MCQ concept. So see this, it is the fundamental concept regarding the transconductance for N-channel JFET. Now at VGS equal to minus 1 volt, drain current decrease compared to VGS equal to 0. So it is the graph between VGS and ID. Now see, it is the equation of drain current. ID equal to IDSS 1 minus VGS upon VP all square. See this equation, highlighted equation. I have highlighted this with the help of circle. See this. See this highlighted portion of circle. ID equal to IDSS 1 minus VGS upon VP all square. Now what is the transconductance? Transconductance can be defined as delta IDSS upon delta VGS. Now take the differentiation with respect to VGS. See this, I have simplified the step here. Delta ID upon delta VGS. So IDSS into 2 multiplied by 1 minus VGS upon VP into minus 1 upon VP. So my 2 IDSS upon VP 1 minus VGS upon VP. So it is considered as a transconductance. It is considered as an equation of transconductance, opposition of resistance. So please be carefully prepare this. Be carefully prepare this. Be carefully prepare this final equation Gm equal to Gm0 1 minus VGS upon VP. Now now next point, which is considered as an amplification factor. Now see, what is the meaning of amplification factor? It is known as output voltage divided by input voltage. See this, amplification factor, output voltage divided by input voltage. So output is delta VDS, input is output resistance divided by input resistance. Sorry, amplification factor means what? Output resistance divided by input resistance. Output resistance divided by input resistance. So it can be considered as an amplification factor. So output resistance at the delta VDS upon delta ID, input resistance delta ID upon delta VGS. Why? Because gate can be considered as an input, drain can be considered as output. So see this ID cancel. So delta VDS upon delta VGS, delta VDS upon delta VGS. So it can be considered as a GM into ID. See, it is known as transconductance. It is considered as a transconductance. GM, it can be considered as a transconductance. Here it can be considered as a resistance. So delta VDS upon delta VGS. That's why output voltage divided by input voltage. So it is known as amplification factor. GM into RD. Basic equation Gm into RD. It is the fundamental equation of amplification factor. Why it is known as amplification factor? That I have proved here. It is the basic equation. See this. Gm equal to this delta ID upon delta VGS and RD equal to delta VGS upon ID. See this, in this page is divided into two parts. Reverse process. It is reverse engineering. I have write here that this is known as reverse engineering. Delta ID upon delta VGS upon delta ID, delta ID cancel. Output voltage by input voltage. Obviously, it is known as amplification. Output by input. So it is known as amplification factor. So it is known as amplification factor. So please write down this value. Mu equal to output voltage by input voltage is equal to Gm into RD. Is equal to Gm into RD. So please prepare very carefully. Now next point. JFET biasing. What is the meaning of biasing? Biasing is used to locate Q point at the center of the DC load line. It is the fundamental concept of transistor. Same that can be applied in JFET. So there are the four types of biasing: fixed bias, collector to base bias, emitter bias, and voltage divider bias. Now see, I have write here in Gujarati words, so all the Gujarati people can try to understand. In biasing method of JFET, Just replace BJT with JFET. BJT ને GFET થી replace કરી નાખો એટલે બધું same થઈ ગયું. And in previous lecture I have also already explained this concept. I have already explained this concept. What is the concept is that? What is the concept is that? See this. Base is equal to gate in JFET, emitter is equal to source in JFET, collector is equal to drain in JFET. That's why just symbol is changed. Just change the symbol of JFET. Don't do anything. Just change the symbol of JFET. Don't do anything. See this. Three type of configuration: common source, common gate, common drain. Common source configuration, it is most useful, similar to common emitter configuration. That's why here source can be considered as a ground, VDD can be connected as a supply, one type of reverse bias voltage. So here drain, here gate, here source, here RG resistor used to control the current, here VGG battery. So it can be considered as the output loop equation. VDD equal to IDRD plus VDS. Obviously here RD means what? Voltage drop across resistor. It is here both resistor are include RG and RD. RG and RD resistor is used to control the current. RG and RD resistor is used to control the drain current. It's used to control the drain current. So it is the output loop equation related to common source configuration. It is the output loop equation related to common source configuration. Now see this. Now see this. It is the most important. Okay, related to GTU examination. Voltage divider biasing of JFET. So in voltage divider, R1, R2, RD, RS. Here negative terminal introduced. So VTH equal to R2 into VDD divided by R1 plus R2. Obviously, voltage across resistor 2 divided by R1 plus R2 into supply voltage VDD. VDD equal to IDRD plus VDS plus ISRS. So it is the concept regarding the JFET biasing. Don't require to do like transistor, but preparation is must be required. So prepare this very carefully. See, this is the golden statement regarding the JFET. For that, from that, definitely MCQ will be asked. Saturation region act as an amplifier. Cutoff region act as an open switch. Ohmic region it can be act as a VVR. VVR means what? Voltage variable resistor. Delta VDS upon delta ID. Simply apply the resistor equation delta VDS divided by delta ID. So it is the concept regarding the junction field effect resistor. Again repeat, it is known as voltage control device. In with respect to transistor, if you can compare, then transistor act as a amplifier in active region. JFET act as an amplifier in saturation region. Transistor act as an open switch in cutoff region. JFET can be act as an open switch in also cutoff region. But in saturation region, JFET can be act as a on switch or voltage variable resistor. Similar in transistor, it can be used in the saturation region to identify the open switch. So it is the basic difference between JFET and BJT. So please try to prepare. It is very useful. Now JFET can be act as amplifier, common source amplifier, common gate amplifier, and common drain amplifier. It is the concept regarding the JFET. It is the concept regarding the JFET. So common source amplifier, simply put the capacitor, RD resistor, RS resistor. So if Vin is applied to the base, then IG current flow. If IG current flow, so IG is increase. If IG is increase, obviously gate current વધારે flow થાય, ગેટ કરંટ વધારે ફ્લો થાય એટલે ડેપ્લેશન રિજિયન ઓછું હોય તો ડ્રેઇન કરંટ વધશે, ડ્રેઇન કરંટ વધશે એટલે સોર્સ કરંટ ઘટશે, ડ્રેઇન કરંટ વધશે IDRD increase થશે તો obviously IT 5DIT is increased, then VDS is decreased. How it is possible? See, consider here the P terminal. I have write here, consider here P terminal. Consider here N terminal. Why? Because N channel MOSFET is present. Here consider also N terminal. Consider the N channel JFET. Consider the n-channel JFET so that for n-channel JFET, if V is applied, then Ig current is flow. Why? Because P terminal contain positive charge. So Ig current is flow. If current is flow, then fundamental law of basic electronics, it says that depletion region width is decreased. I have write this here. If current flow is large, if current flow is large, then width of depletion region, width of depletion region, width of depletion region is decreased. Width of depletion region is decreased. But if current flow is large in gate, then width of depletion region is increased. So, so see here case 1, if current flow is large, then width of depletion region is decreased. Then drain current, drain current, maximum flow, maximum flow. See the construction of JFET related to my previous lecture. If depletion region is high, depletion region is high, width of depletion region is high, maximum, then current flow is minimum. But here current is large, so depletion region which is decreased, then drain current maximum flow. If drain current maximum flow, then obviously IDRD increase because ID is the external resistor. And if IDRD increase, then VDS is decreased. Now see, this is the most important. IDRD increase, then VDS decrease. Why? Because VDD equal to IDRD plus VDS. If IDRD is increased, then VDS is decreased. So if VDS is decreased, IDRD increase, VDS decrease. So it creates the phase shift between output and input. So it is considered as a 180-degree phase shift in common source amplifier. So it is also MCQ. It is also related to preparation of MCQ. Please prepare very carefully. Please prepare very carefully. In common source amplifier, we can get 180-degree phase shift. In common gate and common drain amplifier, we cannot get 180-degree phase shift. Why? Because gate is common. That's why drain current can be equal to 0. If drain current is 0, then we cannot get output current. So it is also considered as a 0. That's why in common drain and gate, common gate equal to common base amplifier, common drain equal to common collector amplifier. You cannot get the phase shift. Only in common source amplifier you can implement the concept of phase shift. Now, now see, this is the example of JFET. N-channel JFET has IDSS equal to 2 milliampere. N-channel JFET IDSS equal to 2 milliampere. 8 milliampere, sorry, and Vp equal to minus 5 volt, means what? Pinch of voltage, and Vgs equal to minus 2 volt. So it is the basic equation of JFET. 2 by 3, what is the weight ratio of 2 by 5? So 5 minus 2 by 3, 3 by 5 whole square. So answer is 2.88 milliampere. So it is the final answer related to example number 1. Now, when reverse gate voltage of JFET change from 5 volt to 4.9 volt, means delta VGS equal to 5 minus 4.9. Obviously, gate to source voltage change here. So 5 minus 4.9 equal to 0.1 volt. Similarly, drain current can be reduced from 2.3 to 2.6 milliampere. So 2.6 minus 2.3 equal to 0.3 milliampere. If you can take the ratio, then it is known as 3 millimho. It is the final answer. Now see similar type of example that can be asked here. When reverse voltage gate 15 volt is applied to the JFET, then current flow is 2 milliampere. So what is the output resistance of the source? So 15 divided by 2 milliampere. Answer is known as 75.10 raised to 9 ohm. Now see P channel JFET. similar to n channel, but sign is changed. Why? Because now current flow from source to drain, current flow from source to drain, and in p channel JFET, current flow due to the hole only. In n channel JFET, current is flow due to the electron only. But holes injected from source and through channel and through forward through the gate. Here P channel is connected. Drain, drain contains the positive supply, source contains the negative supply. That's why that's why if here consider negative supply, then there is no flow possibility of flow of electron. So it is the final condition. See this here. Channel become narrower if VGS is increased, VDD is increased. If VDD is increased, I have write here. If VDD is increased, then width of depletion region, width of depletion region is increased. Width of depletion region is increased. If VDD is increased, then width of depletion region is increased. So drain current is less flow in the circuit. So it is known as VGS equal to 0. So maximum current can be flow. So if VGS equal to 0, then which if the depletion region is increased, so drain current decrease in the circuit. Now see, this is the construction related to JFET. VGS equal to 0, 0 less than VGS less than VP. See, this is the graph of JFET. I already mentioned that plus 1, plus 2, plus 3, plus 4. Obviously, VGS is negative for N channel, obviously positive for P channel. Why? Because P channel directly connected to supply voltage. So only and only if current is flow, if if uh, if we can extend the lockdown from curfew. So it is the P channel JFET characteristics and N channel JFET characteristics. So please try to prepare this video very carefully and please try to understand this video very carefully. Thank you very much.